Hello, everyone. Welcome to another insightful session in our Azure series. My name is Oli. First of all, before we jump into what we have for today, I want to apologize for the delay earlier. We scheduled the LinkedIn Live, but due to some issues and delays, we're not able to do it on LinkedIn. So here's the alternative to jump on a call on Teams. Okay, so we are sorry once again. Okay, I'm really excited to have you join us today as we continue exploring key concepts in technology and cloud computing. So, in this session, we'll be learning about a foundational topic that every tech enthusiast and every cloud professional should understand, which is understanding networking and subnetting. So, to take us through this topic is someone who has an understanding of cloud technologies and a great passion for sharing knowledge, which is the person of Paul. So, Paul will be breaking down what networking really is, how subnetting works, and why these concepts are so crucial in the world of technology. Okay, so we all know Paul. Paul Ogurefo is an MVP, most valuable professional. He's also a cloud infrastructure solutions engineer. So sit back, relax, and get ready to learn something new and valuable. Paul, over to you. Thank you.
All right, thank you very much, Olive. It's a pleasure to be here again. Uh, just to add to our apologies, please bear with us. We were supposed to do this live. Unfortunately, still fortunately, we couldn't due to either technical issues to network issues. But all things being equal, we cannot hold it down or bend to circumstances. We just have to still, kick off, right? Maybe I would want to say our network and subnetting did not, truly align with the goal. And as such, there are interruptions along the line. Okay, so what do we have today? We term it understanding networking and subnetting when we are talking about Microsoft Azure. Why is this concept very, very important? Everything, let's say almost everything you build on Azure relies on network for communication. Right, just get it clear. Almost everything you are building on Azure relies on network for communication. Then I want to ask, what then is networking? Networking refers to the connection of two or more devices to share resources, to communicate, and to ensure proper security, to ensure that, yes, you are supposed to be able to reach that guy and not the other guy, to understand safety, to understand isolation, to understand, okay, this is the point where you need to meet, and this is the point where you shouldn't go or mustn't go. All right. Why is this also very important? In our basic education, even down to our first and second years in the tertiary institution, we must have been told or heard that computer does not understand the human language. If the computer does not understand the human languages and only understand two numbers, which is 0 and 1, that we were taught, how then are you able to write linkedin.com in alphabet? How then do you go to ChatGPT? Do you go to Copilot? You go to google.com and all of those things? It is not a rocket science. There is actually a technology that is working behind the scene that you don't know or you don't see with your physical eyes. Again, networking refers to what? Interconnection of two computers or generally two or more devices. All right, devices can mean printers, can mean computers, can mean even the CCTV cameras and the likes. So what we basically want to do today is not to start digging deep what you can achieve with, network or subnet or what you cannot achieve. See, okay, before I even proceed, let me try to explain what subnet is. Subnet is you just, in simple terms, right, is you just trying to divide the network. There is a network and there is need for you to divide it. Take the note the keynotes there, take the word sub, right? Sub means you are subdividing. So that is basically subnetting so that you can further manage your network in smaller particles. to further help you manage your networks, because at this point you have segmented them in various ways and numbers. All right, you might be wondering what I'm probably doing on my profile. So in this course, I will want to acknowledge where I really got understanding of this concept, which is the ABC of cloud computing platform, where this concept was broken down for me. And in that course, I had to prepare this article at the time. If you see, I opened this article 4 minutes ago on my other system before it shut down. So this is the same material that I'll be referencing today, right? If by any means you would need to, on your own read more, I can, just share this article with you, and then you can, go through it. I think in publishing this particular video, because the call is being recorded, we would have to attach this link to it just to, reference it. So if you see my, what do I call this now? Should I call it a thumbnail? Okay. If you see my thumbnail here, you will see a lot of numbers, greater than 1, less than 1. We have the zeros, we have 8, we have 255, right? I will say computer only understands 0 and 1. And of the truth, the computer send messages and translate messages from within these two numbers, 0 and 1. So here you have 192.168, 100.10. We have 8-bit, 8-bit, right? We have host portion, network portion. Yes, this is basically what I want us to fully understand today. We have the 255, 255, 255. Like there are a whole lot, and then here come the 000 and the 1111. Right. So we are saying IPv4 addressing. So basically we have two kinds of IP address. We have IPv4 and we have IPv6. These are the current kinds of IP addresses that we have, IPv4 and IPv6. However, IPv6 are yet to be in use, right? So we are still within this range. This is what we are basically using at the moment. So what is an IP address? Like we've rightly defined, is a unique numerical identifier assigned to devices connected to a network. So there must be network in the sense of IP addressing. And don't forget, we are discussing networking and subnetting. So we are starting with IP address. That is what we are starting with. And then we have the types of IP address. Don't forget, initially I said we have kinds of IP address, IPv4 and IPv6. And this topic says IPv4 addressing for beginners. So we'll be focusing more on IPv4. All right. So the types of IP address now, we have the public IP and then we have the private IP. The public IP are assigned by us internet service providers, and this can change and vary from time to time depending on the kind of network you are connected to. If you open with me to your browser and you type what is my IP, and you open this guy, what is my IP address? Here you see my IPv4 address is up. This is for me, and it is unique to this my network. You will probably see numbers that are different from yours. So this is basically the IP address that interfaces with our internet because it is public, right? Because it is public, there are what interfaces with the internet. The internet is a public space, like you know, is the internet is the largest network available area, and that is why we call it one wide area network. Okay, so private IP address are used within private networks. This time around, it is not public and it does within on its own. Like your home or office, they are not visible or accessible from the internet, but are essential for local and between devices. And this is strictly used where most especially when you are in a corporate environment.
Hi,
Now,
Paul.
in that corporate environment, within the organization.
Hi, Paul. Can you
Yes,
hear me?
yes,
Oh,
I
okay.
can.
I'm so sorry for interrupting you, but it seems there is a network problem because your voice is not clear enough.
I'm so sorry. I will try to be louder now. Am I good?
Yeah, I know it's network. It's due to network. So sometimes there's a crack in your voice. It goes up, and sometimes I can't hear everything you say. Your word completely.
Oh, I don't know what is happening today, man. I don't just know. Maybe I want to change my network within a short time. Just bear with me 1 second.
All right, no problem. Sorry about that.
Okay, please confirm if I'm good.
All right, yes, I can hear you now.
Okay.
It's better.
All right. So private address, like I was saying, is mostly used in corporate environment, yet that needed to be kept within the environment. In this case, you have to keep them locally and let your devices communicate with those addresses. If you are not interfacing with the internet, you will not be needing the public internet. So what you can use to share information confidentially is this, private IP address, and they are always very unique. So, for example, now I should go to my PowerShell, right? I should go to my PowerShell and I type ipconfig. If I should go ahead and do ipconfig, so I'm expecting it to give me some series of IP address. Now check it out.
All right, can you hear me, Paul?
Yes, I can hear you.
All right, sorry once again for interrupting. Okay, I think your screen is lagging because you just changed the screen right now. It was
Yes,
stopped
I switched to
previously.
PowerShell. Oh,
Okay,
okay.
just seeing it now.
So you
All
see
right, you
my
can continue.
IPv4.
Yeah.
Right, thank you. You see my IPv4 address. This is unique to me. We will get to this point. You don't know why this should be or why it shouldn't be, and why it should be a private IP address, right? But this wasn't what you saw on the internet. As a matter of fact, you will not get to see this particular IP. You will not get to see this particular IP from this end. But just understand the concept that, okay, there are private IP address and there are public IP address. Public IP address are used to interact with the internet, which is the wider, network that is public, while private IP address are used within a private network, right? Private could be corporate environments. Then we have the versions now, IPv4, and then we have IPv6. We've talked about these kinds before. This is an example of IPv4. IPv4, you see it has just 4 octets, right? This is 1, this is 2, and this is 3, and this is 4. In total, they consist of 32 bits, right? 32 bits, while each of the number here is 8 bits. This is 8 bits, this is 8 bits, this is 8 bits, and this is 8 bits. Total of 32 bits for IPv4 addressing. Then again, we have IPv6 address. Now, this is the newer version designed to handle the extraction of IPv4 addresses, yeah, using 128 bits address system. Now, this is the format that is coming with, is divided by a colon, and I think it's about 8 octets: 1, 2, 3, 4, 5, 6, 7, and 8. And if you notice another thing, each of the octets has 4 numbers, and they are also mixed with alphabets. All right. Now, the reason for the introduction of this IPv6 address is because IPv4 are bound to be consumed. What do I mean by bound to be consumed? There are a certain number of IP addresses that are usually available for any IP range. And if you want to talk about IPv4, the number of IP address available and compared to the number of people that are living on Earth, then try to equate it by the number of devices each person will have, knowing fully well that each device ought to have its unique IP address. Then you will find out that the address will not be enough. How do we know? We were saying that the IPv4 address is a 32-bit IP, right? Now, if you want to know the number of IP addresses that are available in IPv4, then you probably want to do this calculation with me. What do? We have the formula that says 2, let's just quickly run that, 2 raised to the power of n, which is the number of networks that are available. That is the number of bits that are varying. And in this case, we have 32 number of bits. So we are going to say 2 raised to the power of 32. Raised to the power of 32. Here we have 4,294,927,296. And we have over 7 billion people in the world, right? So if this is the case, and me myself, I can't count the number of devices I'm actually using, right? Plus my phone has its own IP, from this number, my system has its own from this number, and a whole lot more. You probably on this call, you watching this video, your phone, you want to count the number of people, the devices that people have, you automatically know that, okay, this number cannot serve us all. Now, you now want to see organizations that are using my organization. I can't count the number of devices we have, to be honest, right? Now, how would this number be able to serve everybody? And that was how and why IPv6 has to come into the picture, even though it is still not practically, usable at the moment, based on, somehow we still found our way, using from this guy. Question like, how is this still possible? Yes, that is where subnetting comes. That is what, for example, now 2 organizations can be using the same IP address, right? If my organization is using this in a particular network, another organization can still be using this, and they will not interfere because they will probably be on a different network, even though they are using the same IP address. And there's a way they will do it that all the computers in the organization will just be picking within what they have in their environment without intercepting with what other people have out there. So there are still enough to be consumed. Yes, this will definitely come to light. Is existing already, just that is not practically being used right at the moment. So there's a special note here. We haven't gotten to the part of calculation, and we'll just do that briefly. A special note: we have the IP address 0.0.0, which is either invalid or acts as a default IP address. Then we have the class A. Now, in class A, the first octet represents the network, while the remaining 3 octets are reserved for host. I will explain what we mean by host and what we mean by network. Then the class B, the first 2 octets are for the network, and the last 2 octets are for the host. Then the first 3 octets, so for class C, the first 3 octets are for the network, and the final octet is for the host. One of the most common IP address that we know is from class C, right? In most cases, even on my computer, when I check, I think we're seeing 192.168. If you check your phone right now, it's possible that you yourself will be having an IP address of 192.168, right? This is the private IP address of class C, right? And then look at this. We are saying class A and class C. Now, this is class, if you check from here, right? If you check on this image, this is a class C IP address. And if you come to this point, you see that the first 3 octets here is cycled and it is termed the network portion, right? That means you can use about 24. Look at it, you can use 24 bits on network. Why host here means the number of devices, or the devices, the parts that is meant for devices, the number of devices that can be assigned to these guys. This, do I say number of devices? Yes, this represent devices. Now, if you are using 192.168.100, right? And we have 10 here. Throughout, while you will be using this IP range, the only thing that will be changing for the device will be this 10. The next device that you are probably adding will be 192.168.100.11. It will leave the part of 10, and the next one will take 12. But these 3 will remain constant because it is the network. If we now come, let me see if I have that here. Yes, I have it here. So we are saying public IPs are routable on the internet, while private are not. They are used in offices, for example. Now we now talked about the classes, right? Now private IP ranges include, so in IP, we're talking about public. This is what we have in private IP addresses. These are the examples, right? The first one is the class A. When you see any IP address that is starting with 10, any IP address at all, means that IP is a class A IP address. If I have 10.0.0.0, in this case, this guy will be the network, while this guy will be the host. So from here now, you agree with me that this guy here, this guy, because we have 3 portions, that is 24 bits that you can literally assign to the host, which is the devices that you are connecting to the network, you will have much more IP addresses available here, right, to give to devices than you will have in class C ordinarily. And then this one is still, is still 8. And we now talk about the class B. Class B usually starts with from 172.16. That is how it usually starts, and to 131. So if you see any IP address 172.16.17.18 down to .31, then you are probably talking about class B, private IP address, right? In this case, these first 2 now, these first 2 will now be the network, and if you probably have .0.0 here, this will be the host. This will be the host. In this case, you're having 16 bits to the network area, and you're having 16 bits to the host area. Then we have talked about the class C, which is within 192, which is within 192.168. Anywhere you see 192.168 means that this is a class C IP, private IP address. This cannot be anything. However, even though there can be anything, this last one only represents the host, while this will be part of this network. For class A IP address, there's what we also call CIDR notation, and that is what map IP subnet mask. So for /8, here you see that the class A IP address, the first octet range is between 0 to 127, and the subnet mask is /8. This /8 is a way of actually dividing the network. If you say /8, this means the available bits for that range. Don't worry, we'll come to see how we can do our calculation with this guy. Then from class B, the first octet range is from 128 to 191. The subnet mask is 16, meaning the bits available, we have explained this, 192 to 223. Then we have /24. Then we see have D and E. These are not of importance to us as such. So I was saying, if you go for IP config, you will see your private IP, you will see your subnet mask, and then you see default gateway. This is the default gateway here, .1. That you can just check them out on your PC. Right now, subnet mask is a 32-bit number that separates IP addresses into two parts, right? Into network and host. That is the basic division that it has. So the network portion represented by bits turned on. So in our school, we usually see, in school, we're taught that it's between 0 and 1, right? So definitely the bits turned on, like we see from this picture, you see 11000100, but from here you see 111, 111, 111. And because this is a class C, you see these ones here straight up, and the number that are turned on are 24. And that is why you see this /24 here in class C. So that is what this guy is trying to explain. And equating to a default subnet mask value, a subnet mask value of 255. Now, if you have your 1111 to 8, you will see that, okay, let's just do this calculation briefly. How do I even clear all of this? Let's pick this guy. So let's just do a small demo here. When we are in school, we are taught binary numbers, and if you do this and you do 2, 5, 5, right? And then you divide by 2. If you divide by 2, you have 1 here. I think this should be 20. Is it 24? No, 20. This is 27. You will have remainder 1. If you do 2 here, you have 6 and you have 3, right? You still have remainder 1, because if you do that, you will get 126. You still have remainder 1. If you further divide to 63, you have 32. 32, you still have remainder. Is it 32? Yes, remainder 1. It cannot be 32. Yeah, you have 31. You have 31. So if you divide 31 by 2, you have 15. And then you still have your remainder 1. Then divide by 2 again, you have 7 here. Remainder 1. If you do 2, if you do 2, this one will give you 3. You still have what? Remainder 1. If you do 2 here, you do into 3, you have 1. This will give you remainder 1. Now, if you do 2 here, 2, we have 1, remainder 1. Then if you do 2 into 1, am I even correct? Yeah, you will have 0. And what you are having is what? Remainder 1. Sometimes, you don't even need to do this again. Just pick from here, and then you count up. That is how we are taught, right? But if you calculate this 1, 2, 3, 4, 5, 6, 7, 8, right? If you now want to write it, you say 1, 1, 1, 1, 1, 1, 1, 1, 2, 3, 4, 5, 6, 7, 8. Now, this is as good as what? 2, 5, 5. This is what we were taught, and it is very correct. So, for every octet in IPv4, for every octet, and the complete ones is equal to what? 255. And that is why if you come back to this picture, you see 255, 255, 255 here. Why do we have 0 here? So those 0 particularly means that place is turned off, right? And as such, they will represent the host. Now, the host portion of the IP is represented by bits turned off. So those bits are turned off, which indicates the number of devices, example, computers, printers, etc., that can be connected to the network. This is determined using the formula 2 raised to the power of n, where n represents the number of bits allocated for the host portion. Okay, so basically, we are saying anywhere you see 0, it means that the bit is off. So if you want to calculate for the number of network that IP should have, you calculate by the number of 1 that are turned on. And if you want to calculate the number of devices that can be connected to each of those networks, you calculate by 2 raised to the power of n, which is zeros that are turned off, the bits that are turned off on the part of devices. Then we have CIDR notation, CIDR notation, which is equals to /A/C/24, for example, indicates the number of ones in the network portion. E.g., we have 192.168.70.0. Then we have /24 here. Then we have 172.19.00/16, and then we have this /8. All this means something. Now, I was talking about subnet mask, and we are talking about 255, right? And if you come here, you see subnet mask, we are talking about /8/16 and /24. The truth is, if you are calculating for network, if you have ever come across IP address, right, and you see something like 192.123, okay, let me just be straight, .168.0.0, and you see /24, this is where it ends. But if I don't want to put the 24, I can as well go with 192.168.0.0. Then I'll give it a paragraph to say 255.255.255.0. This, in essence, means the same thing. There is no difference, right? This guy here is still equal to this guy, right? Is still equal to this guy. There is no difference between the two of them. It's just a way of writing this to tell somebody that is probably reviewing your work, to tell you that, okay, this is the number of network that we have here. Okay, this is what we have here. And if this is what the person is seeing in Azure, you most likely see this, right? You most likely see this guy, this other notation. If this is what the person is seeing, the person will as well still understand that, okay, this is where the person is coming from. But you do not just go with IP address like this and you expect the person to know what you're actually doing. So it could be /25, it could be /26, it could be /27, it could even be /32. We are not limited to just 8, 16, and 32. That you should take note of. It could be 17, it could be any number between 1 and 32. Right? That's to take note of first and foremost. Then let's continue from our document. I'm hoping we'll get to where we'll see calculation soon. Okay. Now, there is an example of a calculation here. Yes, this is how we really calculate. Okay, let's start from here. This is CIDR notation. This is me just explaining CIDR notation. So if you have this IP address and you have the subnet mask 255.0, like I just said, and then you have slash 24. I mean, it will definitely give you slash 24, right? Then we have 255.0.0.0, like that. If that is the case, if it's 255.0.0.0, this will probably be slash 16. Is it 16? Slash 8, because this is the only one that is turned on. Then slash 16, and then slash 24. Anywhere you see 255 means there are 8 bits turned on full there. Anywhere you see 0 means there are 8 bits turned off completely there. Now, key calculations. This is where we come to our calculation. Please, if you are designing, hopefully next week we will see how to create these things in real life and how we can, do our subnetting proper and create our network proper, right? This is just to lay foundation. Now, the number of connected devices in a network is calculated by what? 2 raised to the power of n, where n is the number of zeros in the host portion. The number of usable IPs in a network is calculated as 2 raised to the power of n minus 2. Now, these two, okay, this is we subtracting network ID and broadcast address. So in Azure, for every network you created, for every subnet you created, rather, in Azure, 5 IP addresses are not available. From 0 to 3 are not available. Assignment starts from 4. That's why if you create a network and you assign it to any resource that's needed network in Azure, it usually starts with .4. So the first 0, 1, 2, 3 are unavailable for assignment, but generally 5 are not available. 0, 1, 2, 3, and the last one, in this case, let's use 255. Right? 5 are not available for use. But generally, there are 2 not technically available. Sometimes it can be 3, depending on what the design is all about. But one thing you need to note is the first network, the first IP that is within that range, which always starts with, which in most cases, if it's a whole network, 0, right, is not assignable because it represents the network. That is the identity of that network. And then the last IP address is usually the broadcast for broadcasting information, right? Ensuring communication. But in most cases, the second network, so the first network, the second address is not still available, which is .1, right? Now, what doesn't make it available is, in most cases, it is being used as a default gateway network. Now, that gateway is the one that enables communication between this device and the other device. Why subnet distributes, why broadcast, like the word entails, broadcast, it broadcasts the information. So technically it can be 2, it can be 3, but just get it. If you have calculated the number of usable IP addresses, just know that you have to minus something depending on your design. But by default in Azure, there are 5 that are not available. 1, the first. 2, the second. 3, the broadcast. Now, you now want to ask me, what are the remaining 2 used for? What are the remaining 2 used for? So basically, these other 2 are reserved. They are usually reserved for Azure DNS and possibly for future use. But just know that the first, which is .0, is not available. The second is reserved for default gateway. The third is reserved for Azure DNS. The fourth one, which is .3, is just there. And then the last one, which is 255, is reserved. Is used for broadcast. And I need to tell you that for each network, right, that is slash 24, I think I have it somewhere here, so let me not flag. So this is an example. We have 172.168.1.0, and I was telling us that it could be slash 10, it could be slash 24, it could be slash anything, right? In this case, now this 255, we have slash 24. Then the host, we have 8 bits. This is this calculation. I want to calculate this. Now, look at something here. You see that this guy has different number, not 111 is not complete. This one has different number, 1010 not complete, and this one has his own, and this one has his own. But this is on the IP address. It has nothing to do with subnet, which is actually the main thing that is dividing the network. This is just telling you that for IPv4 192, this is the binary number. This is what you now use. This 192, this is 110 that you are seeing here. This is what you now use to do your conversion back to, if you are using /24 and slash all of those things, and you will need to convert it to, subnet mask to stand like this, right? In this case now, you may probably have /24 here. So let's go, and then we have total host. In this case, right, total host 2 raised to the power of 8, because we have 8 that is turned off here, so it's 256. So for /24 IP for /24 network, right, we have a total of 256 available IP addresses, meaning that we can assign we have up to 256 IP that we can give out. If we are now minusing the 2, which is the brokers and the ID, means we can assign IP addresses of up to 254 to devices that are available. We can do up to that, but we can't do beyond that. Then we can as well say, okay, we want to further -1, reserving that .1 or .1 for the default gateway. Right now, look at all of this. Maybe we'll just do one small calculation. Look at all of this. You see 255.255.0, it will give you /24, right? If it gives you /24, it's the total IP address that are available with 256. If you are doing /25, meaning you are borrowing 1 from the host to the network, you must turn one thing on. You must turn 10 on. And if you turn 10 on, this now the available one becomes what? 25. We have 24 before, plus this one, it becomes 25. That is why we have this /25, right? If we have /25 and we now have 7 here, if you do 2 raised to the power of 7, if we do 2 raised to the power of 7, we have equals to 128. So we have up to 128 IP addresses. If you want to do /26, how do we now convert? How do we now get 224 from here? How do we get 224? How do we get 192, 128, 255, 255, 255? Everything is turned on. Now for this one, that's /32, everything is just for the network. Knows that available IP address will just be 1, right? And meaning you cannot assign it to anything. This one too, /31, available network will just be 2. And you have subnets, we have ID and default gateway. We can't assign it to anything, right? But if you now come here /30, mean if you are reserving 2, you still have 2 to give. If you are reserving 3, you still have 1 to give, right? So for IPv4 addresses, if you are doing this, when we call that place network area, if you are doing /32, means you are dividing the network into 256 networks. And because we have 256 IP addresses, 1 for each network. Okay, so how do we now get this 254, 252, 248? The number varies, right? The number varies. I'm not sure if I put it down here. Okay, I will just quickly do that calculation and then we'll wrap up, right? Now let's pick a number from here. What number are we picking? Let's pick /27. Now /27 means we have 27 to network and we have 5 to what now? We have 5 to the host and it's /32. So how to get this 244, right? I can just come here and do this guy. Rather than using this method that we were taught on how to calculate our binaries, this time around, I'm going to do something a bit different, right? So we have, for you to calculate, you don't need to be doing all of these guys. You don't need them. Just go ahead, write your 2 into 8. 1, 2, 3, 4, 5, 6, 7. Let me cut from here. And then we have 8, right? So if you want to calculate anything on IP, just do this: 0, 1, 2, 3, 4, 5, 6, and 7. Don't forget, anything that has to do with IP, 0 is important. That is where counting starts from. So 2 raised to the power of 0 will give us 1. 2 raised to the power of 2 will give us, of 1 rather, will give us 2. Then it keep on multiplying. This will give us 4. And this will give us 8. And this one will give us 128. Let me just quickly round off with this calculation. 128, right? Now, for us to get that number, there's another table. Here's the table. Just write 1. Let me do it this way. 1. Let me widen this guy. Just do 1, 2, 4, 8. What is it again? It's 16,
10,
32, 64, 128, and then we have 256, right? Now I will come down. I'll start from here again. 256, 256, 128, 64, and 1. So in this case, I will do this /24, /25. Okay, yes, /25, /26, and /32. Now, then I'll say 255, 255. Okay, take this to be the host. This one will be the network. This one will be the host. And this one will be the CID arrow. So anywhere you see /24, know that there is only one network available there. In class C, please, we are dealing with class C, and there are 256 IP address and a /24. If you see 2, there are 128 IP address and 25, meaning the network has been divided into 2. Okay, now if it now happens that we have /25, let's say 256, right? If we now have, what were we using? We are using 256. Let me see, /224. Yes, we are using /27, right? /27, meaning that only 1, 2, 3, 4, 5 is off. Then 3 are available. So in the context of class C, what I will just do to get my 244 is to use the host for my calculation. Now, I will just go ahead. How many hosts are turned on? There are 3. This one is cycled out to this point. So we are making use of this, and this. This is just to explain the network for you, right? So if I now come to do, there's my calculator. If I now come to do 128 plus 64 plus 32, I'm expecting it to give me 224, right? But if it is now /27, /28, you know that, okay, /28, I'm borrowing 4. The remaining zeros are 4. So I will just cancel this out again, this 4, and then I will add this one. to say plus 16. So if I go ahead to say plus 16 and enter, it will give me 240. That is for slash 28. Let's see what we have here. 280 and slash 28 to see 240. So, and if it is just slash 26 that you are borrowing 2 from, you just pick the 128 and then you add this to plus 24, 64 rather, and then it will give you 192. So that is how to calculate it basically. And if you are creating Azure network, always take notes. For me, these classes does not really work as such, but it is also important that you take notes. This is the most important part. Take note of this side annotation, right? Because in your network, if you go to create a network of slash 24, no, let's say you go to create a network of slash 26 and you succeed. You now want to create gateway subnet, you may be having problem because the minimum example is slash 26, right? If you go ahead to create a slash 24 IP address and you have the mind to create subnets, right? Subnets that you'll be using for different resources, you can only create from 25 upward, and the only 25 you can create are just two, and then you are done. If you try to create 24, you will have issues. So it is always better you go with the one that has more available IP addresses. So for class B now, for example, we have 2 raised to the power of 16. So these are the number of, if you are creating it, you will see it. These are the number of available IP addresses you can create, right? If you now say, okay, you have created the network, it is one. You now want to segment it and put it into subnet. If you go to create for subnet and you are using slash 24 for your subnet, meaning you can create, let me just copy this down, right? Then if I now go to say, okay, I want to be creating slash 24, that means I can just do 2 raised to the power of 8, because then we have 256 IP addresses. From here, from this number minus, okay, let's say divide. Let's just divide 256. That means I can create 256 different subnets for different purposes. So I will have a lot to use in that case, right? But if I go ahead to do slash 24, I may be setting myself up. I'm not able to really do a lot or enough on the long run if I have the plan to use the particular network for a whole lot of stuff, right? And again, yeah, sure, there are several kinds of subnets you can create in Azure that we'll get to see on our next class, where Olive will be taking us, and how we can create our network really live. The number of IPs you can get, you'll be seeing them as she's entering them, hopefully, and then maybe we'll get a clearer picture. But just take note that 255 is the subnet mask. This slash whatsoever is the side annotation. You will get to see all of those next week, hopefully. So at this junction, I think this is where I draw the curtain. The time is already fast spent, and if you have any question for me, please, you can bring them on. You can message me on LinkedIn. You can comment it under the comment section. You can even go as far as sending me a mail if possible. All right, so this is where I draw the curtain. Thank you for listening.
Whoa, this is amazing. Thank you very much, Paul. Like, a big thank you to you. This was such an insightful and practical session. I really enjoyed it. I'm sure every other person would. So thank you very much once again for simplifying the concepts of networking and subnetting, from understanding how networks enable us enable communication between devices, to seeing how subnetting helps manage and organize those networks. Like, really, this session truly provided the clarity many of us need to strengthen our technical foundation. So for our viewers, watchers, followers, please, if you found this session helpful, please like, share, drop your key takeaway in the comment section. We would love to hear what part stood out for you the most. And please don't forget to follow us for more sessions. Just like Paul mentioned, we will continue exploring important topics in technology and cloud computing. So thank you very much for watching. Thank you, Paul, once again for this excellent presentation. And until next time, please keep
See you.
learning, keep building, and keep exploring the world of technology. Bye.
Bye. Thank you. Bye bye.